Assalamualaikum to Dr. Fairuz. So my name is Aina Irdina from Group 6 and my fellow members are Nur Shafiqah, Nur Shahelly, Mansor and Siti Aisyah. So we're going to present about a non-destructive testing for site investigation. Without further ado, let's start with introduction. So for introduction, non-destructive testing (NDT) is a testing and analysis technique used in the industry to evaluate the properties of material components, structure, or system for difference in properties and weld defects or discontinuities without damaging the original part. So, ground radar is the method that we've been chosen. GPR is a geophysical method using electronic technology. This method transmits and receives radio wave and explores the underground. GPR utilizes electromagnetic EM wave of radio wave that react to changes in electromagnetic properties in shallow underground. The propagation velocity of EM wave, which is the main control factor for the generation of reflection, is determined by the relative permittivity ratio or ratio between layers between the background material and the target. So moving on to literature review. The method of EM is based on the measurement of magnetic field changes due to subsurface electromagnetic properties using a coil receiver or dipole antenna placed on the ground or on the surface. Active EM is the method uses an artificial EM source. The passive EM method uses a natural EM field as an energy source. Most active EM equipment consists of a set of multiple loops, coils, or antenna that act as transmitter and receiver. The response field signal sent by the transmitter is picked up by the receiver and used for underground structure analysis. Equations derived are based on the report.
Hi, my name is Nur Shafiqah Mansor, binti Mansor, and I'm going to explain about the methodology. So, as for the diagram shown above, this is the electromagnetic geophysics from ground penetrating radar. So, it transmits the signal of radar and it will receive from the reflected signal to display unit. The GPR can detect more than 1 meter depth underground and it is successfully employed to investigate the near surface for various applications. So the ground penetrate radar method has transmitting and receiving unit, control unit, display unit, and also the power supply. So as we can see on the slide, the GPR is depending on the antenna frequency, where the low frequency have a great penetration but lower resolution, and for the higher frequency limited penetration but better resolution. And so for the antenna frequency 1500, it is for maximum penetration depth for 0.5 meter and it is appropriate application of assessment and rainbow mapping. And the next one is 900 is for 1 meter depth, which detecting pipes and voids as well as determining concrete thickness. The next 400 is for the penetration depth 4 meter and it is suitable for utility inspection, as for assessment, storage tank discovery, and structural integrity assessment. And the last one is the 270 MHz and for maximum penetration depth with 6 meter and it is suitable for geology, archaeology, and utility surveys. So, the antenna delivers brief waves of electromagnetic radiation through the material for the GPR equipment to detect on the site examination. Hence, the part of this energy is collected by the antenna when it comes into contact between materials with different dielectric characteristics, so that the GPR can detect any kind of materials under the ground.
Hi, my name is Siti Aisyah binti Ab Rahim. I'm gonna explain about the result and discussion part. So here we got the table of obtained result of ground penetration radar GPR technique. So data is analyzed by using non-destructive methods and result in predicted by ground penetration radar technique. Gamma ray transmission and ultrasound technique demonstrated GPR ability to detect defects. The obtained link between the features of GPR, drilling of test and girdle cutting permittivity is from 6.4 to 7.4. Further, the extreme depth of perception is 44 cm. Antenna located on the outward of the sample and the air is 29 cm offset.
Assalamualaikum. Hi, my name is Haekal, and I'll continue with the conclusion. So, there are many types of application that can be applied based on GPR, ground penetration radar, but then based on this slide, this is mainly focusing on geological engineering. So the first application is mapping route of field layers in terms of geological investigation. Second one is borehole GPR, which the purpose is to determine the degree of fracturing of the roughness and development faults. The third application is mapping thickness of ice on glaciers along with the location of pools of ice poles for climate change measurements. And the last, detailed mapping on sedimentary stratigraphy that relates to pipeline crossing. It means by using technique of GPR that the process will begin with penetration through water, which lessen the amount of water by using salt water. So this mapping covered for both land and also beneath rivers, particularly for pipeline crossing. Right. So the condition, there are a few conditions that will help getting greater result by using GPR technique. The first condition is the diverging reduction properties of earth materials that can be affected to better result. It means the particular properties will prevent of gravel or sand from leak out. And the second is the depth of penetration must be identified by spreading the radar signal in the ground. This is because the small size of characteristics such as cracks and joints are the target for the radar that will signify the signal as the frequency increases. So in a nutshell, in this project, the aim of non-destructive testing has been identified, which by using a technique of ground penetration radar, that is the best and common techniques that use especially in geological engineering. And in terms of obtaining the best result, well, it will be much easier if handled by someone that experts or well-trained person. That's all from us. Thank you for watching and Assalamualaikum.